what we're going to look at today is something that you'll be seeing later on in like Algebra 2, okay, as well. So this is not just something you're going to learn in geometry and then forget about. This is something that's going to show up again later, I promise you, okay? So, and it's a little tricky, but again, we'll try and get it down here, okay? So we're actually going to, this is the section, we're going to start here, but we're actually going to skip into the, we're going to skip some into it. We're not going to do this like little exploration or anything like that, but the basic question that we want to be able to answer is, what do we know about the side lengths? We're not going to worry about the trigonometric ratios yet, so don't worry about that. We'll learn more about those on Monday, I think. So what do we know about the side lengths in special right triangles, okay? So, we have two right triangles that we, for some reason, or not some reason, because there's like special relationships that happen between the sides, we kind of learn more about those kind of special right triangles. The first kind of special right triangle we look at is a right triangle like this. Maybe we'll go through this one, okay? This one, okay, if you look here, by these two markings, what do these two markings mean, anybody? Congruent. They're going to be the same, or congruent, exactly right. So therefore, since we have 1, 2 congruent sides in this triangle, how could I name this triangle? Isosceles, that's right. So this triangle right here is an isosceles right triangle, all right? Now this is a special right triangle. That's what makes it kind of special. It's got two congruent sides here. So, if these two sides are congruent, what can I maybe say about angle A and angle B here?
Oh, they're
They're going to be equal to, right? They'll be congruent as well. But we can say even more. We can actually say what the measure of those angles are. What would the measure of these two angles have to be? 45. How'd you get that, Matt?
Because the right angle is 90, and then there's two others, 90 divided by 2 is 45.
So, right, if you guys remember there, right, the angles in the triangle have to add to 180 degrees. If we subtract off that 90-degree angle that we know, we're left with 90 degrees, like Matt said. If these two are equal, he knew he could just divide that 90 then by 2, and that would give us the 45-degree measure. That's true for both of those angles. Okay? So an isosceles right triangle will always have a 45, 45, and 90-degree angles. And in fact, that's sometimes how we refer to this triangle. We refer to it as a 45, 45, 90 triangle. I'll put that like in quotes because that's like how we name it. Okay, sometimes it's called a 45, 45, 90 triangle. And you can see that, okay, so for example, if I know that side BC would be like 3, what do I know side AC would then have to be? 3 as well, right? Because the sides are going to be congruent. We can be even more precise, so we can actually come up with a little way to know what AB is going to be. So we can figure out AB here. If I know two sides, or if I have two sides of a right triangle, and I want to find that third missing side, what can we use to find it? Yeah, Pythagorean Theorem, exactly right. We're going to find the Pythagorean, you're going to use Pythagorean Theorem, okay? So we're actually going to skip, we actually did did A through C right there, so we're going to skip down to the letter D right here. All right, we're going to try and find this hypotenuse. I'm going to call that C, a little c. And so now let's just set this up. So it's going to be leg squared, so it's going to be x squared. The leg is x, okay, plus the other leg squared, so another x squared. Okay, and we want that to equal the hypotenuse squared, so that would be c squared. Okay. So now this is a little bit weird, right, because we have all these variables and there's no numbers. We can actually like solve this or simplify this sum, okay? So if I have one x squared and I add another x squared, I have 2x squared because we're adding. So x to the fourth is if I was multiplying x squared times x squared to be x to the fourth. Since I'm adding 1x squared plus 1x squared, I now have 2x squared, and that equals c squared. Okay? But again, we're not interested in c squared. We want to solve for this side c here. So to solve for c, to get the c by itself, Xander, what should I do to both sides here? If I want to get the c, I don't want c squared, I just want c. So what do we have to do to undo a square? We don't divide by a square. What's the thing that cancels out a square? It's not subtraction or division. It's square root. Square root is what we want to do. So we square root both sides. Sorry, did you have a question, Ramel? To this right here? It's all 2s. All the numbers are 2s right there. Okay? So the square root of c squared, that leaves us with just c. I'm going to flip this equation around. And the square root of 2x squared, well, that's that. Can we simplify? Are there any perfect squares in there that you see?
Yeah.
Yeah, what's the perfect square in there?
4.
I don't see. There's no 4 in there.
2.
2 is not a perfect square. X squared is a perfect square, isn't it? It's a something squared. All right, so we can actually simplify this, break it up into square root of 2 times the square root of x squared. And what's the square root of x squared? It's just x, yeah. So this becomes then the square root of 2 times x, or in the normal way that we write it, we normally write it as x times the square root of 2. Okay.
It's not going to be on the test, right?
Yes, it will be on tomorrow's quiz. Yes, okay. So, x times the square root of 2, that is your hypotenuse there. So if this side's x, this side's x, this side's going to be x times the square root of 2, up in that special right triangle, the 45, 45, 90. Now, you might be wondering again, why we just do that? What's the point of that? Well, let's go back to what I said before. All right, let's go back to what I said before. If I say that BC has a side length of 3, what's AC's side length got to be? 3, because the x is 3, right? If I know that BC is 3, I also know that AB's side length then is going to be 3 times the square root of 2. If this is 3, that's like the x, right? And then that's going to be 3 as well, because this is also just x right here. And then this side, it's going to be x times square root of 2. Well, if my x is 3, it'll be 3 square root of 2. Okay, so we can find, given only one side, we can now find 2 missing sides here in this special right triangle. So if I said like BC was 3, that means AC, right, is 3, no problem, right? I mean, it's because of the same. They're both congruent, they're both x's there. Well, from what we just solved down here with using the Pythagorean Theorem, AB would be that x times the square root of 2. No matter what x is, it's going to be, what's that? It's a decimal. It's like 1.7 something, I want to say. Right. But again, it'll be that. Okay. So it'll be 3 times the square root of 2. It'll be your side length there. Without having to do Pythagorean Theorem, you just, okay, if that's 3, that's 3, and that'll be 3 times the square root of 2.
So when we get that, we say that.
Or you can just leave it as 3 times the square root of 2. That's fine. Remember, we can leave square roots and stuff like that too. So, okay. So that's that special right triangle. And then there's another one, but we're not going to go through the proof with maybe. All right, we'll give it a shot. All right, so let's go to the next page there. 710, next page over. Okay. We're going to look at the other special right triangle that we'll be responsible for, and then I'll show you how we're going to use this in problems and stuff. Okay. So, start out here with letter A. It says triangle ABD is an equilateral triangle. So ABD is an equilateral triangle, meaning that AB, BD, and AD are all congruent, right? If we draw BC a perpendicular to this side AD, okay, we can determine these like 3 measures here, for example, in triangle ABC. So in an equilateral triangle, all right, in an equilateral triangle, what are the angle measures in an equilateral triangle? Oh, Derek's not here. Let's go to Maddie. What are the angle measures in an equilateral triangle? Do you know what the angle measures are in an equilateral triangle, Maddie? No? Okay. Dominic, what do you say? What are the angle measures in an equilateral triangle? No idea? All right, hold on a second, Hulu. Let me see if I can get one more person here, and then we'll go to you. Oh, she's not here. They're right. Okay, they're all going to be equal. So, Jason, what does that mean they're going to be then? What degree measure will they be?
90.
So, if you have 3 90-degree angles, that adds up to 270 degrees. That's too big.
No. 60.
60 degrees. 60 degrees. So, angle A is 60 degrees, angle D will be 60 degrees, and angle B, the big angle there, will be 60 degrees. Okay? Now, we want to determine, it says here, determine all 3 angle measures in triangle ABC. So again, the way this is set up, if angle A is 60, angle C is 90 degrees, what is this angle? How can I figure out what this angle's got to be here? It will be 30, right? It's going to be, this will be 30. Yeah, no A squared plus B squared, that's for sides, right? That's for sides, not for angles. Okay, so there's the 3 angles. So this special right triangle, okay, this is called, if you look here, we take this triangle out, they pull it out, and they draw it by itself right down here. So again, this is the 60-degree angle from there. That's that 30-degree angle. And this is called a 30, 60, 90 degree triangle because the three angles are 30, 60, and 90. And again, this is the second special right triangle we should be familiar with. Okay? Now it turns out that this hypotenuse, okay, and we can kind of figure this out, and I'm going to go for it. Why not? We'll see how we do here, okay? We're going to try this. So again, if we say that AC is a length of x, what's the length of AD going to be then? 2x. X plus x, so 2x. The full length here is 2x. And since this triangle is equilateral, what does that mean BD's length will be? 2x as well. And AB's length?
How did you get that?
So if AC is x, CD is also going to be x.
Mm-hmm.
Okay? And so that means the total length is 2x, right? X plus x, 2x. Okay? And so then, since this triangle is equilateral, what we were told, ABD is an equilateral triangle, therefore BD will be 2x.
Yeah.
BD, and then AB will be what? 2x. And so if I go back down to here, this one, that means AB here is going to be 2x, right, based on that picture that we had up there. Okay? This triangle is just pulled right out down to here. This triangle on the left side here, this like triangle, is pulled right out and put down there. Okay, so one side's 2x, one side's x. So that means, for example, if AC has a length of 4, what will AB's length be?
Wait, what?
If AC has a length of 4, what will AB's length have to be? 8, yeah, twice that. 8, yeah, exactly. But we can also figure out what BC's length is. And again, we'll use the Pythagorean Theorem. Okay, so let me just show you that. So in this case, we're going to find, we'll call this side A, because I don't know, and it's opposite the A there. So we'll call this side A. So we'll do A squared plus x squared, again, because that's our other leg. So our two legs squared, add together. Okay? Yeah, this is the formula for it, yeah.
Oh, I don't like this.
So the formula on the other
I know, it's tricky, Jason. I hear you. Yeah.
The formula on the other page is different from this one.
This is a different, because it's a different special right triangle. Different special right triangle.
But we're supposed to know all these formulas by tomorrow, and
You should be familiar with both of them, yes. Mm-hmm.
well, we just learned it. Like,
That's right, but that's what math is. You have to learn stuff. So I'm still like debating EK, but I want to say right now, yes, we need to know that. Mm-hmm. So I'm debating about whether I will give you guys the special right triangles for the quiz. Oh, by the way, it's a quiz, so you get to use your notes. Right? So yeah, Ren. Mm-hmm. Your notes, yeah. Mm-hmm.
like when it says equals, do you put just 2x or you put 2x squared?
Quantity squared, exactly right. Quantity squared, like that. Okay? Because it's the whole side is 2x. We're going to square the whole side. Okay. So I know again this is a little bit tricky, and again if you don't quite get this this part down, like that's okay. I'm just trying to show you where this comes from, and then later I'm going to show you how to do the problem. So if you're having trouble with this, I'm kind of okay with that. But then when we go to actually do some problems, then you really want to make sure you get that part down. Okay. So this part's a little fuzzy. That's okay. That's okay. But I'm just trying to show you where we get these relationships from. If I square this, I get 4x squared, and then I have still a squared plus x squared. Okay. Again, what we're interested in is we want to solve for the side A here. We want to come up with like what must the formula for this side BC here be. So I want to isolate a squared. I want to get a squared by itself. So what's with the a squared? And anyone just want to tell me? Jason, why don't you face front, because I know there's nothing to learn back there right now. Okay, you should be looking up here. What should I do to this equation here to get the a squared by itself? What's with it? Subtract x squared from both sides. Ugh, I keep writing smaller and smaller. I'm sorry, Ramel. I know you're having trouble seeing.
So that is D4.
So it becomes a squared, and now actually, yeah, so good question. 4x squared, take away an x squared, what do we have left?
X squared.
3x squared.
Wait, 3.
Yeah.
It's 4x squared, we're taking away 1x squared, so it's left with 3x squareds total when you subtract it off. Yeah, subtraction. And then we square root both sides to get the a by itself. And I get a equals the square root of 3x squared. But we see a perfect square in here, don't we?
Yeah, X squared.
Yeah, so what's the square root of x squared?
No,
X.
But I thought you took away the x squared. Why is it 3x squared?
When you subtract 4x squared, when you do 4x squared, take away x squared. So you have 4x squareds, you take away 1x squared, you're left with 3, right? And I know, I see what you're saying. It's like subtraction, things cancel out. But it's because we have 4 of them, we're taking away 1 of them, we're left with still 3 of them left over. I understand. It's a hassle. But, okay, and so there's the relationships right there. There's, oh, sorry, you can't see that third one. There you go. There's our three relationships. So if I know side AC, for example, if I know side AC is 2, then AB will be twice 2, 4, and BC is going to be 2 square root of 3. Those are the three side lengths. Without having to do Pythagorean Theorem, just knowing that special right triangle relationship, 2, 4, 2 root 3. Yes, Brian? This way?
Yeah, that was thinking.
Is that good enough? Okay. You're welcome. Thank you for asking. Okay? So that's our special relationship. Now, if you guys turn to the next page, you'll see those at the top of the page. You'll see those at the top, right? You can see both special right triangles. And then just below that, you'll see some problems that we're actually going to do. So again, if this was fuzzy, that's okay. I just wanted to kind of like show you guys where this comes from, and then we'll actually get into what we're going to do with them now. Okay? We're actually going to like do some problems now.
Can we like practice them?
Yep, that's what we're going to do right now. Exactly right. We're going to practice them right now.
So like, what's the point? Like, what? Like, you're trying to find A, but like.
So what I was trying to do right here was just show that we have, in these special right triangles, they all the sides relate to each other. So the power of this is that when we use Pythagorean Theorem, for example, how many sides do we need to know in order to use Pythagorean Theorem? We need 2, right, to find that third side. In this case, I only need to know one side, because if I have a special right triangle, if I know, for example, this side, if I say this side again is like 3, let's say, that means I know that this side, the hypotenuse, must be twice 3, 6. I know that this side must be 3 times the square root of 3, so 3 root 3, whatever that is.
Why is that side 6 now?
Because of the relationship of because like again, the reason why this one has to be 6 is because of how we got it, how it came to be. We took this equilateral triangle, which was all the same side length of 2x here, right? So basically, it's just like it's how we got it. From this here, it yielded these relationships. Because of the way this triangle is set up, it yields these relationships.
You said AB is 6.
Right, because if AC is 3, for example, that's like x is 3, right? So AB then is going to be twice that x. So it's going to be twice 3, 6.
But there's not a 3 saying it's 3.
Well, I'm just saying, hypothetically, if we were given a triangle, because right now this triangle is a very generic triangle. It's all x's in here. But if I were to draw a triangle that's a 30, 60, 90 triangle, and I said this side is 3, therefore, this side would have to be 6, and this side would have to be 3 times the square root of 3. Has to be, those relationships. Yes, Brianna?
Or why didn't we do the top one?
The top one, because it's like, if you look here, Brianna, this triangle right here, ABC, if you like take that out, that's what we did right there.
Oh, okay, I was just wondering because I wrote it down, but then I remembered it.
Yeah, no, this is what, because we wanted to finish it off. We got this triangle from this. That's why we started with this one, we pulled it out, and just looked at this one right here. So, again, back to the next page, on page 711, you can see there are your relationships, okay? This is something for the test that you will need to have, and I'm sorry that you have to, memorize it. For the quiz tomorrow, you'll have your notes, so you don't need to worry about memorizing it, but for the test, you'll need to have this down, because I can't give it to you. You need to know the relationship. The benchmark requires that you guys know this without a formula sheet or anything like that, so I have to have you have to know it, okay? So, let's actually see these in practice, finally, here, okay? And, actually, I kind of want to do something a bit easier than this one. So we'll start, so we're on page 711, So we'll do this one in a second. I'm going to draw an easier one first to start out. So let's start with a triangle right here. I'm just going to do this easier triangle first, because otherwise it's going to be, I think, too much. Okay? So, start with the right triangle here, and again I'll say it's a 45, 90 triangle. Okay, I'm going to label some of the sides. I'll say that this side is length, I don't know, I'll say 3. Okay. So, in my 45, 90 triangle, if I look up here and try to match it up, what does this 3 match with in my 45, 90 triangle? Yeah, if I look here, my 3 is opposite a 45-degree angle, and opposite a 45-degree angle in this picture is an x. That means, in this problem, that 3 is the same thing as x. The x is 3 in this case.
So why didn't we match it up to the other triangle?
The other ones, we were coming up with this relationship. We were like showing this relationship. Now we're going to use this relationship.
No, I'm saying why didn't you match it up to the other one? Why did you...
The other ones that we drew?
No, what? You just...
This one right here?
No.
This one here?
Yes, you took the one, you took the triangle you just drew and you matched it up to that one. Why didn't you match it up to the one to the right? It would still be the same answer for that specific side, but it wouldn't be for another side.
So what we're going to do here is, this is like an example problem is what I want to say. So we're solve for the missing sides, are my directions. Sorry, I maybe should have specified here. These are just for like us to have so we can see these relationships. So I don't want to put like numbers in there because that's what we're supposed to like know. I'm going to now do a problem and we're going to use this to help us solve it. Does that answer your question?
Not really.
Okay. So I didn't want to put the 3 in here because I want to have this like kind of generic triangle right here.
Like, I'm asking like, so you see how the triangle beside the one we just used?
This one.
Right.
Okay.
See how that has an X on the bottom?
Yes.
The same one as the other one,
Yes.
to the left of it. So we're using both those triangles, correct?
We need to be able to use both these triangles, yes. And
so when you're solving for the missing side,
yes.
You're looking at what the 3 matches up to, and let's just say the triangle to the right has x plus 2 instead of the triangle to the left, which just has an x. What do you do then?
Oh, so, well, I wouldn't use this triangle. And can anyone explain why aren't we using this triangle here for this problem? Why aren't we using this triangle? It's a 30, 60, 90, right. It's not a 45, 45, 90 triangle. We want to use this one. So that's how we know to use this one.
Okay.
And then that's the idea there, okay? It matches up the angles. Okay. Sorry, thank you. Okay, moving on. So again, this side right here is a length of 3. That's the x side. What can I label this side as? It's opposite of 45 as well, so it's also an x, and therefore it's going to be equal to 3 as well. Okay? And then this side right here, it's opposite the 90-degree angle, and what can we label the side opposite the 90-degree angle? X times the square root of 2. Ooh, okay. Alright, so you want to label the parts. Label the parts from your generic kind of 45, 45, 90 triangle in there. And then we plug those pieces in. Okay? So, if x is 3, that means this is going to be x times the square root of 2. So x is 3. So we can just say that this, okay, then is equal to, this is then the 3 times the square root of 2. X is 3. So there it is.
Wait, how did you get that?
X is 3 according to these other side, like right, this side right here was x, so that matches to the 3.
Oh, so
and
the x's are first.
Yep, in this problem, x's are 3. X's are the 3. Okay? Once you find the x, then the rest of the problem kind of like is finished. Okay, you just have to then just like fill in the missing pieces. Once you find x, then you can find the rest of the missing pieces. Okay? All right, let's do another one here because I know this is still pretty tricky. All right, so we're gonna do this one right here. So we're not gonna go very far. We're just gonna go on to this one. Again, we can see it's a 45, 45, 90 triangle. So I won't use this triangle. We're gonna use this one right here. Okay, the 10, this side right here. What does that match up to in my 45, 45, 90 triangle here?
X squared.
X times the square root of 2. So in this case, 10 is equal to x times the square root of 2. Okay? 10 is equal to x times the square root of 2. Now, what would I label this side as? What does this side match up to over here? X. And what does this side match up to over here? X as well. So I need to see this equation here. This side length is 10. Like AB is 10. That's true. But I need to figure out what x is in order to know what these side lengths are. So what do I have to do to both sides of my little equation here to get what x is? Divide by what? What's with the x?
2.
Square root of 2. So then x, if I divide both sides by the square root of 2, so 10 equals x times the square root of 2. So we'll divide both sides by the square root of 2.
How do you even do that?
So, good question. I'm just going to leave it as 10 over the square root of 2. You could make it a decimal if you wanted to, or you can just leave it as that.
Can you actually do that?
Like write this, or do it as do it in your calculator. Yeah, you can do that in your calculator. I'm going to leave it as this though. So x is 10 divided by the square root of 2. X is 10. divided by the square root of 2. So that's the two answers. Sure. Those are your two answers, though. Okay, questions on that? I know it's tricky. We're going to look at another one here. Okay, we'll look at a 30, 60, 90 triangle. So I know this is not easy. Okay, so there are your three sides, though. 10 matched with the x square root of 2, so we had to solve for the x. By dividing both sides by square root of 2, we get x is 10 divided by the square root of 2. So it means this side is 10 over the square root of 2, this side is 10 over the square root of 2. And that's the side measures. Okay? Ready for another one? Questions on that? Some people are like, I'm done after the first one? Okay, well, we still need to keep moving on. Okay, so here we go. And the 30, 60, 90 triangle, again, I'm going to draw that other picture over here. Remember the 30, 60, 90 in the picture up top looks like this. It's got a right angle, 60 degrees there, 30 degrees here. This was 2x, this is x square root of 3, and this is x. Derek, you can wipe that off, please. All right. And this is high school, by the way. I don't know if you what you think this is. So take one of those tissues, please. Thank you, and wipe it off. Is it your bad? I don't think you're really. It's the second time you've done it now, so you're just sad you got caught, I guess. Maybe not. Just don't do it again, please. All right. This is high school. I know you like to laugh. It's fun, but it's obnoxious too. And I hope you don't get sick because I don't know who touches that. Okay. So anyway, this is our 30, 60, 90 triangle. Notice it's not in the same orientation, but what does this 5 square root of 3 match up to here? And that's a little bit trickier, isn't it? Yeah, exactly right, Haley. It's x. How are we able to tell that it matches up to the x?
There's a right triangle in the bottom.
Mm-hmm. And if you look here, go ahead, sorry.
It's like right next to the hypotenuse.
Yeah, if you look here, the x is between the right angle and the 60 degrees, and so is 5 root 3 between the right angle and the 60 degrees. You can also think opposite. Opposite of 30 degrees is the 5 root 3, and here opposite is x. Okay, so that's how we label that. How do we label side DE then, according to this? It's going to be 2x. Again, it's opposite the right angle, so opposite the right angle here, there should be 2x. And then opposite the 60-degree angle, how should we label this side? X times square root of 3. Okay? So now that we have all these things labeled, all I have to do is, I have to just take my x here, which is 5 square root of 3. So again, 5 square root of 3, that is the length of that side. We don't have to do any work to that. And it's already x. So that means here, if I want to find the length of this side, I have to do 2 times what? 5 times the square root of 3. So it's just going to be 2 times 5 square roots of 3.
Why don't you multiply it by the x square root of 3?
Say it one more time.
Why don't you multiply it by x times the square root of 3?
Because the x is 5 square roots of 3. The x is the value, 5 square roots of 3. That whole thing together, it's 5 square roots of 3. So, yes, Josh. Yeah, exactly right, Josh. Exactly right. That simplifies to 10 times the square root of 3. So this side right here is 10 square roots of 3.
Can you show us how to simplify that?
Yeah. Well, Josh, what'd you do?
2 times 5.
Yeah, just 2 times the 5. 2 times the 5. Because they're not in square roots, so they can multiply and make just 10. The square root of 3, it's in a square root, so we just leave it as square root of 3.
If you can divide by square root, you can multiply, correct?
Correct, and it is being multiplied. I mean, there's like a little time symbol between the 10 and the root of 3 there. Yeah. So, yeah, Josh? So let's take this. So it'd be 5 square root of 3 times square root of 3. So this is a little bit funkier. Ramel, I don't know, what's going on over there? You can go to the nurse?
I don't know.
Okay, if you decide, let me know. Otherwise, can you cut it out, please? Thank you. All right, 5 times the square root of 3 times the square root of 3. And if you're not sure what that is, let's just type into our calculators. 5 square root of 3 times the square root of 3. Ready for that? Whoop. I had a problem here. There we go. 5 square root of 3 times square root of 3. 15.
And where did you get 5 square root of 3 times square root of 3?
So again, this side, that relationship, it's opposite the 60-degree angle. So according to my 30, 60, 90 triangle, opposite the 60-degree angle is x times the square root of 3. Okay,
So
that's the relationship.
Why are you multiplying x square root of 3 times x square root of 3?
So in this case, again, back to the original thing, if this side, since we were told that it's 5 root 3 and that matches with the x, that means all the other x's in here are the value of 5 square root of 3 in this problem. So 5 square root of 3 times square root of 3 gives us 15. That's what we do with it. Okay. Let's try another one here. I know guys were like beating a dead horse, but we need to get some more practice in, I think, because I don't want us to be stuck here. So next page, we have 2 here for us to look at. Okay. Yes, the homework will be in the book. Yes. Okay. So let's try these last 2 here, and then we'll I'll give you guys your assignment if we have any time left, which we might not, but okay. So again, real quick here, let me redraw. Let's see, 36. Nah, I'm not going to make you guys do these on your own, so no worries. Okay. So again, I'm going to redraw those special right triangles just so we have them handy to reference.
Can you put on, like, and turn it down?
Okay. So we're going to have these handy to reference. So you can see those, right? Again, you will not need to know these by heart for the quiz. You need to know how to use them, but you can reference these. You will have these to reference for the quiz tomorrow. All right. The test. Well, so Jason, I mean, I understand. We have flex today. If you want to get some extra help on it, and we'll work on it together. Yes, Josh. Yeah. Let me get everyone caught up here, and then we'll absolutely have you do that. Yes. Okay. Absolutely. I'll take that at the end, then, Jason. But yeah, I'll absolutely pull you. Just remind me. I'll ask at the end and just say it then. Okay. Okay, so far so good. We've got our special right triangles. This is something you will have. We need to know how to use it, though. So we'll go to this first picture right here, number 5. Okay, let's just label it. Okay, so Josh, you said you want to do this one, so you're the star here, Josh. So this 4 root 3, what does that match up to? Which one of these sides does that match to?
Wait, which one did you say?
The 4 square root of 3. This side right here.
That matches up to 2x.
Yes, very good. How are you able to tell? Yeah, it's just flipped. You can also see it's opposite the right angle, right? And so therefore opposite the right angle here is 2x, so that's how we know those 2 things are the same. Okay, so then Josh, what can I label this side as? JK. It's not going to be, it can't be 2x, it's x, that's right. It's opposite the 30 degree. And then what's this side right here? Yes, good job, Josh. Excellent. All right, so Josh has got half the battle right there. He's labeled everything correctly.
Leave him there for the rest of the year. He's very smart.
Okay, thanks, Jason. Josh, I'm sure, really appreciates you saying that too. Look at that. He's really happy. That's there you go, Jason. I'm not. Yeah. Anyway. Okay. So Josh, you are doing great though. Thank you. So what's the next step here? I need to figure out what x is, don't I? I have the 4 root 3, which is this side. 4 root 3 is this side. I got to figure out what x is. What do I got to do to both sides of this equation here, Josh, to solve for x? I want to get x by itself. What's with the x I got to get rid of? What's with the x? Yeah, here's my equation, right? My equation is 4 square root of 3 equals 2x. What's with the x I got to get rid of? The 2, so I got to divide both sides by 2. I'm sorry, I didn't hear you say that. Okay, what's 4 divided by 2? 2, so we just have 2 square root of 3. That's our x.
What?
The square root of 3 doesn't have to divide by the 2 because the 4 cancels out with it. So it just is 4 divided by 2. I'll get you that here in a second. Christian is... Okay, so 2 is the square... So x is the square... 2 square roots of 3. So that means this x right here is 2 times the square root of 3. That side is 2 times the square root of 3 in length. Okay? And then what about this side? I have to do 2 square roots of 3 times what? Square root of 3. And again, if you want to, you just type that in your calculator. 2 square root of 3. Whoop. Goodness. 2 square root of 3 times the square root. It's 6. It's 6. Okay. Okay, so where did what 2 come from?
All those twos that are up here.
Again, it's from this special right triangle right here. This side right here is the hypotenuse, so it matches with the hypotenuse up here, 2x. And so we need to figure out what x is, because this side's x times root 3x. So I got to figure out x. I divide both sides by 2. 4 root 3 divided by 2 is 2 root 3. That's x. So there it is. Then this one's x root 3, so I take this very same x, plug it in for x here. 2 square root of 3 times the square root of 3 gives me 6. All right? We're going to keep going here, guys. Got one more here. So let's take a look at number 6. We're going to go to the bell here, guys, because I'm not, we need to make sure we get this down. So we're not going to just, so don't pack up. Yeah, I'll get that to you in a second. We have plenty of time, so no frets. No frets, okay? All right. If you just want to come up and get it here on your way out, Krishna, I'll give it to you, and then you can head on out, okay? Okay, so I got the homework here for you, Krishna, when you come up. All right, last one here, folks. Shh. Look, I know you're gonna have this for homework. I need you guys to listen up because I want you to be able to try and do this. Okay. There you go, sir. You want to put that in your pocket or something like that. That's the homework. Okay. Shh. Okay. So let's look at this last one right here. Okay. Again, this is a 45, 45, 90 triangle, so that matches to this. 45, 45, 90 triangle matches to this one, okay? What does the 2 root 6 side match up to here? The x, so it's equal to x, okay? This side, what do we label that as then? It's x as well, right? And then this side is what?
2x.
Yeah, x times the square root of 2. So, if this side PR is x, that means 2 root 6, that is that length, it's x. What does that mean this length has got to be? 2 square roots of 6. And then this side, okay, we're going to do x, which is 2 square roots of 6. I'm going to do it on top because I kind of run out of space below it. Times the square root of 2. It's going to be a decimal, okay? So you can give me the decimal, or we can actually simplify this. The 2, what does that multiply with here? Shh. Guys, excuse me. Shh. You need to listen for this. Dominic, Jaden, eyes up front. Bell's not rung yet, class not over. You need to be paying attention. Okay, this is going to be on tomorrow's quiz. I am not going to not do this because you guys decided to not listen, okay? It's going to be on there. We'll take some time tomorrow before the quiz to review, okay, to look back over it, but these will be on the quiz. You need to know how to do them, okay? So, shh. Not yet, Mel. I'm talking. You need to listen, okay? I'm trying to teach this. You need to listen. 2 square roots of 6 is the x value, okay? Times the square root of 2, right? X we just said was 2 square roots of 6. We plug it in for x. Times the root 2. When you multiply these, the roots can multiply together, so it becomes 2 times the square root of 12. And then you can simplify it, or you can do the decimal. Okay? So I'll just stop there because we're running out of time now. Okay? 2 square roots of 12. Your assignment. Okay, I'm going to give that to you, and yes, I want you to try it.